So now in this question, we want to figure out what the hybridization is around the N atom and NO2 with the -1 charge and NO3 with the -1 charge. Now to figure this out, we have to first do the Lewis structure for both of these chemicals. And to do the Lewis structure, we need to know the number of valence electrons. And to do that, we need a periodic table. So let's pull up a periodic table. So here's a picture of the periodic table, and what you need to know is everything in this column in here is going to have 8 valence electrons, except for helium. Helium is going to have 2 valence electrons. Everything in this column in here will have 7 valence electrons. Everything in this column in here is going to have 6 valence electrons. Everything in this column right here will have 5 valence electrons. This column right here will have 4. This column right here will have 3. And we're going to skip this part of the periodic table and come over here. This column right here is going to have 2, and this column right here will have 1. And what you need to know is we need to know N and we need to know O right here for this problem. And N is going to have 5 valence electrons. So whenever we do the Lewis dots for N, what you're going to do is you're going to put an N down, and then we're going to put 5 dots. Now you can imagine you have like a box around this N right here, and each side of this box can hold a maximum of 2 dots. And what you want to do is you want to take these 5 valence electrons and put them around this N right here. Each side of this box can get 1, and then if we have to double up one side, we're going to double up as few as possible. And so what we're going to do is we're going to take the 5 electrons and we're going to do 1, 2, 3, 4, and we spaced them out as much as we could, and now we have to double up one of these sides in order to get 5 valence electrons. So I'm just going to pick any side I want, and you can pick this top side and put an electron right there. So we have this top side with the 2 dots, and then we have this side, and this side with just 1 dot. And so each of these sides wants to form a bond, and this right here side, this top side, is going to have 2 valence electrons, so that side's full. And so you could think about this in terms of how many valence electrons, or you could think about it in terms of how many bonds. So nitrogen has 5 valence electrons, or you could say it wants to have 3 bonds. And those 3 bonds are going to be this one, and this one for where it's going to come from. And so if we have oxygen right here, it's got 6 valence electrons. So when we put oxygen down and we put this box around the oxygen, we have 6 dots. We're going to do this. We're going to do 1, 2, 3, 4, and now we have to double up one side. Now it doesn't matter which side I put the other dot on, as long as I just filled up with just 6. And so I can put 1 here, and then I can put maybe like 1 over here. And so this electron there and this electron there, those want to form bonds. And so for oxygen, it's going to have 6 valence electrons, or we could say it's going to have 2 bonds. And so it wants 2 bonds, and it's going to have 2 lone pairs. Nitrogen has 3 bonds, so it wants to form 3 bonds, and we'll have 1 lone pair. And so now that we know the number of valence electrons or the number of bonds, we can go back to the problem now. And so if we look at the problem, we say we got NO2. So what I'm going to do is, I know that N wants to form 3 bonds and oxygen wants to form 2 bonds. So I'm going to go ahead and put oxygen right here in the middle because it forms the most number of bonds. And what I'm going to do is I'm going to put oxygen here, and I'm going to put an oxygen here. And what I'm going to do is I'm going to try to make nitrogen have 3 bonds, and that's the way it typically will form. Not always, but what you want to do when you make these Lewis structures is you want to have a 0 formal charge on all the atoms. And if nitrogen has 1 lone pair and forms 3 bonds, it's going to have 0 for a formal charge. And so that's what I'm going to try to make this nitrogen look like. So I can do 2 bonds here to this oxygen here, and then I can put a lone pair there and a lone pair there. So this is exactly what we said we want oxygen to look like. It matches what we just said on the periodic table. And nitrogen wants to form 3 bonds. Well, I have it forming 1, 2, it needs 1 more bond, so I can do 1 bond like this, and then I can put this lone pair in like that. And this is exactly what we just said a second ago. We said nitrogen wants to form 3 bonds, and it's got 3 bonds, and it also has this 1 lone pair. But this one right here, this is not what we want to have for oxygen. We want oxygen to have 2 bonds, and look, it's only got 1. And so what we need to do is we need to figure out how many dots is going to go around this oxygen right here. Now keep in mind, I have this -1 charge right here. So what I want to do is I want to put the -1 formal charge on one of these atoms. And the atom I'm going to pick is going to be this oxygen right here. And the reason why I want to pick this oxygen right here is because, well, for two reasons. One, it only has one bond attached to it, and it normally wants to have two. And so I know there's something off about this oxygen. So that's the reason why I'm going to target this one as the formal charge equation. And the other reason is because oxygen is a very electronegative atom. And when atoms are very electronegative, they pull electrons towards them in a bond. And that's going to make this one have a formal charge of all of these different ones. And so what I'm going to do is I'm going to put the -1 on this oxygen right here. And so for my formal charge equation, what that looks like is this. The formal charge is going to be equal to the number of valence electrons minus how many bonds I formed plus the number of free electrons. And free electrons, that's just basically how many dots there are around a particular atom. It represents the valence electrons that are not bonded to anything. And so we're going to use this equation for this atom right here. And so we want to have a -1. So I'm going to put a -1 for the formal charge of that oxygen. And that's going to be equal to the valence electrons of oxygen. Number of valence electrons is going to be 6. So I'm going to put a 6 down. And then I'm going to do minus how many bonds I formed. Well, I only formed one bond with this oxygen right here. So I'm going to put one bond plus the number of free electrons. And so when I solve this equation right here, I'm going to get a -1 equals 6 minus, now I need to put a 7 right here in order to get a -1 here. So that means this part of the equation has to be equal to 7. And so if I have 1 plus what, it's going to be 7, that's going to be 6. So the number of free electrons is going to be equal to 6. So that tells me that this right here needs 6 dots. So I'm going to go ahead and put 1, 2, 3, 4, 5, 6. And this is what the Lewis structure will look like for this NO2. So now we can move on to the NO3 with the -1 charge. And what I'm going to do is I'm going to put the N in the middle here. And that's because this N wants to form 3 bonds typically, and the oxygen wants to form 2 bonds typically. And so by putting the N in the middle right here, I can try to get it to bond the most number of times to this oxygen. And so I'm going to have oxygen here, and then oxygen here. And what I'm going to do is I'm going to try to get this N to bond 3 times and oxygen bond twice. So if I do a double bond like this, the oxygen has bonded twice and the N has bonded twice. So the N can bond one more time. And this oxygen, this is exactly what I want it to look like. So I'm going to put its lone pairs in there. And so this is exactly what we said a second ago. The oxygen wants to form 2 bonds. And this N right here wants to form 3 bonds. So if I do something like this, I can make this N right here bond once to this oxygen. And now this N is exactly what I want it to look like. But the problem is I have oxygen here, and they all have to be bonded together somehow. And so what I'm going to do is I want to get the oxygen to have a 0 formal charge. And so what I can do is if I do something like this where I put a double bond in here and then I put the lone pairs in here, this oxygen right here is exactly what I want it to look like. And this N, however, is not going to be what we want it to look like. So that tells me I'm going to have to do the formal charge equation for this N right here. And now what I want to do is I have this oxygen here that's not bonded to anything. And so what I'm going to do is I don't want to bond it here, and I don't want to bond it here. That's because this oxygen right here is good, this oxygen right here is good. And so I'm going to bond it up like this. And so that tells me this is not what it typically looks like, and this is not what it typically looks like. And so I'm going to do the formal charge equation for both of this one and for this one. And so if I look up here and see that I have this -1 charge right here, and if I'm looking to see if I have oxygen and I have nitrogen, and which one am I going to try to put the negative formal charge on, it's going to be the oxygen, because oxygen is going to be more electronegative. So I'm going to put the -1 on this one right here. Now, when you do these formal charge equations like this for these Lewis structures, you always want to make sure that you have as few formal charges as possible. And so if I'm going to put a -1 here, I want this N right here to have a 0 formal charge. That's because of this entire molecule, this has to have a -1 formal charge. So if I put the negative here, that means I can't have anything right here. And it's also kind of good to know that oxygen, because it's very electronegative, it will typically have the -1 charge, and it's going to have the Lewis dots look kind of like this. If I have these 3 lone pairs around this oxygen like this, that's going to be a -1 formal charge for oxygen. And so now what we have to do is we have to figure out how many dots are we going to put around this N right here. And to figure that out, I'm going to go back to my formal charge equation, and I'm going to say that the formal charge for this N right here is going to have to be a 0. So I'm going to put 0 for this N right here, and that's going to be equal to the number of valence electrons for N, and that's going to be 5. So we're going to have 5 minus how many bonds did we form? We formed 1, 2, 3, 4, 5. So I formed 5 bonds, and I'm going to put plus the number of free electrons. And so if I solve this equation for the number of free electrons, in order to get a 0, I need to do 5 minus 5. So that tells me this number right here is going to be equal to 0. So the number of free electrons around the N is going to be 0. And so I'm not going to put any dots around this right here. But the problem is I have more than 8 electrons around this N right here. And remember, every line has 2 electrons. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 electrons around this N right here. And the N can hold a maximum of 8 electrons because it follows the octet rule. Some atoms can break the octet rule if they have a d orbital, but the N in the electron configuration only has an s and a p. And so we can only have 8 electrons around this N right here. And so what I'm going to do is I'm going to have to break one of these bonds right in here and put this right here on this oxygen over here. And the reason why I did that is because the oxygen is very electronegative, so it's going to pull electrons towards it. So what I'm going to do is I'm going to erase one of these bonds in here, and I'm going to put 2 dots right in here. This is where that bond was, and I'm going to have this be a -1 charge here. But if we look up here, this is going to be a -1 here, and this right here is going to be a -2. So now I have the problem of making this N right here. I want it to be a +1. That way I can have +1, -1, and then -1 here. So if I do a +1 and then I have 2 negatives, it's going to equal a -1 here. So I got to get this right here now to be a +1. And so what I'm going to do is I'm going to erase this 0 right here, and I'm going to put a +1, and it's got 5 valence electrons, so I have to have a 4 right here, so I can do 5 minus 4 and get a +1. So the number of bonds I'm going to have is not going to be 5 anymore. It's going to be 1, 2, 3, 4. This will be 4 there. So the number of free electrons is still going to be 0. And so this right here is going to be the +1 formal charge. And so now what I can do is I can count how many domains are around this N and this N, because these are both the Lewis structures for NO2 with the -1 charge and NO3 with the -1 charge. And so what I'm going to do is I'm going to count the number of domains. And what a domain is going to be the number of lone pairs. So we have lone pairs plus the number of bonds. And those two things together are going to make up the domains. And if I have just 2 domains, then the hybridization for that is going to be an SP. If I have 3 domains, then the hybridization of that is going to be an SP2. If I have 4 domains, then the hybridization of that is going to be an SP3. And so I want to go around this N right here like this, and when I do that I have a double bond there. Now this bond right here, this bond can either be a single, double, or a triple. They all count as just one domain. So this would count as one domain there, and then this right here would count as one domain there. So that's going to be 1, 2 domains, and then I have this lone pair, and so that lone pair is going to be 3 domains. So this would have 3 domains. So because it has 3 domains, that means this N right here is going to be SP2 hybridized. And so now I want to go to this N right here. So I'm going to go around this N here, and when I do that, I'm going to count all the domains around it. So I have a single bond there, that's one domain. I have a double bond there, that's going to be two domains, and then I have a single bond there, that's going to be one domain. So this has three domains. And so if it has three domains, that means this N right here is going to be sp2 hybridized. And so the answer for this question is going to be A. They're both sp2 hybridized.